Hi all, welcome to CodAffection. This is the second video in this series of building complete auth system with Angular and ASP.NET Core Web API. In previous video, we have implemented user registration. If you haven't watched that, please watch that first before watching this. Links are given in video description and inside the first comment. Now in this video, we'll discuss all about implementing JSON Web Token user authentication, login and logout with Angular client and ASP.NET Core Web API using the ASP.NET Core Identity Framework. Starting from designing the beautiful login form and then discussing everything you need to know about JSON Web Token, how to implement user authentication with ASP.NET Core Identity, implementing logout feature, organizing Program.cs file. All of these and more are discussed with recommended best practices. So I'm sure that you will find this tutorial helpful going forward in your career. So please watch till the very end. Now after this video, in next part, we'll be implementing user authorization using role-based authorization, claim and policy-based authorization, and with that, we'll be establishing protected Angular routes. So stay tuned through subscribing the channel if you haven't yet. As always, before starting this video, I would like to ask you a favor. If you find this video helpful, please show your appreciation through likes and shares. So first of all, we'll start with designing the Angular login form and then we can go ahead with implementing the user authentication inside the Web API. So without further ado, let's get started. In previous video, we have designed the user registration form with this component registration, which is inside this parent component user. Inside that, we also need to create this child component login. Inside that, we can design the login form. Now, through this login form, when a user is successfully authenticated to the system, we have to redirect the user to the dashboard. For that, we also have to create a component called dashboard. So let's open the terminal. Inside this terminal, we are already running the Angular app. So let me open one more terminal and let's create these components here. First of all, we have login. So here we go, ng, G for generate, C for component. Let's create the component login inside the folder user. So here we have the new component login. And along with that, we have to create one more component for dashboard. So here it is. Now, at present, we are directly showing the user component inside the default app component. Now, instead of that, from now onwards, we have to use Angular routing because we have multiple pages to show. Previously, we only had the registration form. So we have to make use of the tag router outlet. To make use of this tag, first of all, make sure that the corresponding component is already imported this router outlet here. Now let's go ahead with setting the required routes for this application that we can do inside this TypeScript file app.routes. So first of all, let's add a route for the user registration. For that, we can have this object. Inside that, first of all, we'll provide the path as user. With this path, we want to show the component user component, which is the parent component. Now, inside the app, if you use this URL /user, the registration component is getting rendered inside the parent user component. Because at present inside the user component, we are directly showing the component for user registration as you can see here. Instead of that, I will provide a router outlet here also. To make use of this router outlet inside this template, first of all, we have to import the same inside the TypeScript component here. Router outlet. See, at present with this route here /user, only this user component HTML is shown here, which is the wrapper div that we have provided for the user registration component. So with this route /user, the first user component is replaced in place of this router outlet. Now, in order to replace the second router outlet inside the parent user component, we should be providing routes corresponding to the children components. For that, inside this parent user component route object, we can add an array children having routes corresponding to the components login and registration. So here we go, path is equal to sign up, and we'll be showing the component registration Now, along with this path, if you append this sign up, we will show this registration component inside this wrapper div here. See, it's because the first component is replaced inside the first router outlet, and the second router outlet inside this user component is replaced with the component that we have inside this children array. Similarly, with a login route, we have to show the login component inside the same wrapper div. So here is the path login, and we want to show this component login component. So if you try this URL, user/login, see, inside the wrapper div we have the default text from the login form component, as you can see here. Now finally, I want to make one more modification inside the routing configuration. It would be better to remove this parent component path user. From now onwards, in order to render the child components, we only need to pass the child path, and the respective child component will be rendered inside the parent component like before. So in order to render the user registration form, we just need to provide sign up, and that of the login form will be like this. Okay, now let's go ahead with designing the login form inside the component here. So first of all, let's import the required modules, common module and reactive forms module. Now let's inject the form builder like we have done inside the registration component here. We have injected the form builder inside the constructor, and with that we have created an instance of form group. So let's do the same inside this login component. Here we have the constructor. Let's inject the form builder. Now we can create an object of form group with this form builder like this. Just invoke this method group. Inside that we can pass an object having different properties corresponding to different form controls that we need inside the form. First of all, we have email. Let me copy paste that from this registration form group. Let's import this validators. For this control, we'll only set this required validation. So we don't need this array here. Now we need one more control for password. So these are the two properties corresponding to the login form text boxes, email and password. Now let's open the corresponding component HTML file. First of all, we need a form element. We don't need this action attribute. Instead, we will set this property form group. Here we can provide the name of the form group object that we have created. Now let me copy paste the control from the registration form. Let's copy paste this div corresponding to the full name. Placeholder will be email. Form control name email. Now let me comment this div corresponding to the validation error feedback. Let's copy paste this div for password. Placeholder will be password, and here is the form control name. Finally, we need this submit button. Let me copy paste that from here. Inside the button, we will show this sign in. Now let's show a heading like we have done inside the sign up form. You could see the corresponding div here, this one. Sorry, in previous video, we made a small typo. This text should be shown inside an h2 element having this text class here. So here it is, h2 element having the class text success. Inside that we can show this sign up. Now let's remove these two from here. That's it. Now let me copy paste the same inside this login form component. So here is the title sign in. Now let's see how it looks like inside the login component. Instead of navigating the component through URL, let's provide back and forth navigation inside the sign up and login form component. So first of all, inside the registration component, just below the heading sign up, we can have this div. If you already have an account, you may want to navigate the login form. So here is the hyperlink having bootstrap classes, text, decoration, none. So this bootstrap class will disable all of the default styles added to the hyperlink. Let's set the font weight to medium, and let's set the font color to green. In order to show both of this caption and this hyperlink in a single line, we can have this bootstrap class d-inline block. Inside the hyperlink, we will show this sign in. Now, in order to set the destination URL, we can make use of this Angular attribute router link that will be /login. In order to make use of this property router link, first of all, we have to import the same inside the TypeScript component here. Router link. Now you know what, instead of this path login, let's use sign in. So let's change that inside this app.routes. Sign in. Let's change that here also. Sign in. Now if you click on this sign in, you will be directed to the login form. Now inside this login form, we need a navigation back to the user registration form. For that, let me copy this div and pasting the same inside the login component just below the header like this. So here we have the caption, don't have an account. If that's the case, you can go to this route here, sign up. And don't forget to import the router link inside the TypeScript component. See? Now later, in this back and forth navigation, we'll be adding a fade in effect with Angular animations. We'll do that later, okay? Now let's deal with the validation inside the form. The validation is pretty simple. Both the controls, email and password is already set as required fields. Now let's go ahead with displaying the validation error feedbacks along with the respective controls. For that, back to the login form component and let's uncomment this copy pasted div from registration form. First of all, here we have the function has displayable error, deciding whether we want to show the validation error for the given control or not. So first of all, let's copy the function from the registration component here. Has displayable error. It would be better to define this function somewhere globally accessible for all the components. For the time being, for both control, I will define the function separately. So to this function, we'll be passing the name of the control. And here we have written a Boolean expression deciding whether we want to show the validation error feedback or not. So as you know, the control must be invalid and either the form is submitted or the user is engaged with the control or the user changed the default value inside the control. This property is to be defined inside this control, which is indicating whether the form as a whole is submitted or not. So let's define this property is submitted, which is of the type Boolean. Initially, its value will be false. And during the form submission, this property will be set to true. We have already discussed them in great detail in previous video. So to this function, for the first component email, we'll pass the name of the control as email. First of all, we'll check whether we want to show the validation error for this control or not. And here we are checking whether we have a required validation error for the control email. If that's the case, we'll show this error feedback. Please enter your email address. Now at present, for both of these control email and password, we only have a required validation. So this is enough. Let me copy paste this for password. We'll invoke this function with this parameter password and let's pass the same here also. If there is a required validation for password, we will show this. Please enter your password. See, the validation is working perfectly fine. Now to this form, let's wire up a function for the submit event. So here we go, ng submit. We will handle the event inside this method on submit. Let's define the function inside the TypeScript component on submit. First of all, we'll set this Boolean value to true. For now, let's print the form data into the developer console. For that, we can make use of the form group object. From that, we can access this property value. Let's open the developer console. Let's try with a random data. Submit the form. That's it. All of the data that we have given inside these controls are properly getting posted. Now before going forward with implementing user authentication in ASP.NET Core Web API, let me make few more modifications inside the wrapper div. First of all, whichever form we have inside the wrapper div, we should place it in vertical center. And as part of this wrapper div, let me add a logo of this application. So back to the parent component user. To show the app logo, I will make this div as a raw div for the bootstrap grid. So here we have the class raw. Inside that we need two columns with respective column clauses. Call md5 multiply by 2. Inside the first column we will show the app logo, and inside the second column we will render the component, either it is user registration form or the login form, which we already have here. So let me cut and paste these bootstrap classes to this column class here. Now let's move this div into it. Now inside this first div, let's show the app logo. So let me add this image application logo into our app directory, public directory, like this. So here we have the img element having these bootstrap clauses. We'll set the width to 50%. And let's add a bottom margin of the range 3. We don't need this alt attribute. Now into this src attribute, we can pass the name of this image. For that you could do this, just drag this image into this editor and just hold shift and then paste it here inside the src attribute. We only need to pass the name of the image since we have pasted them inside this public folder. And then just below the image, we can have this h2 element having this bootstrap clause font weight bolder. Inside that we can provide the name of the app, which is auth.ec. Now for these two elements, I'm going to add a wrapper div having these bootstrap clauses text sender, and let's set the text color to white. Let's move these two elements into it. Now this div will only be shown in screens having larger width. Otherwise, we will hide it with this clause display none. Now let's set the background color to success. Let's apply the border color on left hand side of the range 4. Now along with this MD clause, we want to set the display to flex. So here we go, display in MD width, set it as flex. Now in order to always align the content in sender, we can apply these clauses align item sender. Along with that, we have to set this clause justify content sender. So here we have the div that we have just added. Sorry, there is something wrong with the corner radius. Sorry, here we have a typo. That's it. Now as part of being responsive, we have hidden this logo in smaller devices. At that time, we want to show the second column in full width. For that, we can add this clause called 12 so that this div will take the entire width in smaller screens. Now adding this extra logo div here added more width to the wrapper div. So we have to change these responsive clauses accordingly. Instead of MD, let's set it as LG, and this LG should be replaced with XXL. In large screens, we will take 6 columns and offset of 3. So here we have the final result. Now as I said already, in this back and forth navigation, we'll be adding a fade in effect with Angular animation that we can do later. Now let's go ahead with implementing the user authentication with JSON Web Token inside the ASP.NET Core Web API. First of all, we'll start with discussing all the things that you want to know as a prerequisite to user authentication. And then we'll implement the user authentication in ASP.NET Core Identity using JSON Web Token. In previous video, we have given a detailed introduction to ASP.NET Core Identity and we have implemented user registration. From now onwards, the discussion on the framework ASP.NET Core Identity could be split into 3 parts. So first of all, we have client. It could be any API Explorer like we used previously, Swagger UI, or it could be Postman, or it can also be client-side applications developed in Angular or React. So whatever that is capable of making an API request into the Web API project. And then we have the Web API itself developed in ASP.NET Core. And finally, we have the database. In this project, we are using SQL Server DB. Now for better clarity, I will split the Web API into 2 parts. So first of all, resources, you could think of them as various web methods inside the Web API. And then we have the framework ASP.NET Core Identity. Now in previous video, we have discussed user registration, in which we have created a new user or new identity into the identity solution that we have. So from the client side, we have made a post request into this URL. Along with the user details, we also pass user credentials like email and password. And the respective Web API method handle the request by saving the pass user details along with the credentials into the SQL Server DB with the help of ASP.NET Core Identity Manager User Manager. Now, as a next step, we are going for user authentication. So let's start with the definition itself. Authentication is the process of determining a user's identity. So during the authentication process, the Web API expects the credentials which is first passed to the Web API during the user registration process. Now, it is the responsibility of the Web API to check whether there is an identity with the given credentials. So that's what we are going to implement as part of user authentication in this video. So the process authentication involves authenticating a user and responding when an unauthenticated user tried to access a restricted resource. So as a first step towards implementing it, first of all, we have to add the respective service into this iService collection here. It can be done simply with invoking this method add authentication from the service collection. So here we go, builder.services.add authentication will add the respective services for authentication. Now into this method add authentication, we want to pass the argument saying how we want to authenticate the user, whether we want to use JSON Web Token or any other authentication standards. Before that, I want to discuss the involvement of the framework middlewares in this process of identity solution. Now, when it comes to an ASP.NET Core web application, whether it is an MVC or Web API, both the incoming request and the outgoing response must go through some established middlewares inside the project. In this given illustration, you could think of these vertical blocks as different middlewares. Now, if you are not familiar with ASP.NET Core middlewares, you could go through this in-depth article. I have given the link in video description. So basically, there will be a chain of middlewares in between the actual request and the destination of the request, and there will be similar middlewares while returning the response. You could think of these middlewares as a common necessary interruptions for the proper working of the app, and each one of them works one after other in sequential order. So the order does matter. Now inside this table, you could see the available built-in middlewares in ASP.NET Core framework. Some of the middlewares will be added by default into the project, and rest of them could be added as per your requirement, like these authentication and authorization in this project. Both of them should be added into this project with the respective method. Just now we have added the required services for authentication purpose, and through this method we will say how we want to configure the authentication. But it won't add the necessary middleware into this application. For that, we have to invoke the use method use authentication. That will add the necessary middlewares for the authentication purpose. And that also must be done in the proper order. Among the middlewares that precede the authentication middleware, the course middleware is the closest one in sequential order, which we have already done in previous video as part of user registration. And then we have to add the middlewares for authentication and then authorization. So this order must be followed. So that's what I have shown as an example inside this illustration. This order must be followed. And most importantly, all of these middlewares must be added before adding the Web API methods inside this project. We have to do the authentication or authorization before accessing the protected resource. Then only we can protect the resources from unauthenticated user. So first of all, here we have the course middleware from the previous video. And then here we have the method invoked by default inside this project, use authorization. It will add the necessary middlewares for the authorization, which we have not discussed yet. We'll do that in an upcoming video. We have added these two middlewares, course and authorization. In between, we have to add the middleware for authentication. For that, all we have to do is just invoke this method, use authentication. So with this method, add authentication, we will add the necessary services to the app and configure how we want to authenticate the user. And such a logic will be executed with the adding of this middleware here. In between these middlewares, course and authorization. So hope you understood. Now with this method add authentication, we want to specify how we want to authenticate the user. Now, before getting into the implementation, I think it would be more helpful if we organize the terms that we already heard of related to authentication or authorization. I mean, the standards or protocols that we most often use for authentication and authorization. At the same time, we are not getting into any details of these standards here. In this tutorial, we are only discussing JSON Web Token. I just want to make you aware of the alternatives that is related to this topic. In that way, you will not get frightened when you hear these fancy terms while you research the topic further. So first of all, we have OAuth 2. So that is a standard, which is then extended into this OpenID Connect, in short OIDC. And then we have JSON Web Token. So these are the most commonly used or most well-known standards for authentication and authorization. Apart from them, you could see Security Assertion Markup Language, SAML, System for Cross-Domain Identity Management, and then we have finally Web Service Federation. If you want to know more about these standards, I have given the link to this article in video description. You can go through them and could study more about these standards. In this particular tutorial, we are using this standard JSON Web Token, in short pronounced as JWT. Now regarding this topic of authentication and authorization, you could see various categorization like based on different aspects of the process like password authentication, then biometric authentication, etc. and etc. All of the categorizations are done based on different aspects in the process. Okay. Now, before discussing JWT or JWT authentication in detail, we should be familiar with one more type of categorizing authentication methods. They are session-based or cookie-based authentication versus token-based authentication. These two types of authentication are more common when it comes to implementing authentication, particularly in web applications. While going through the documentation itself, you could see the terms like token-based authentication or cookie. So learning how these two types of authentication works and how they differ will give you a clarity on this topic of authentication. So first of all, we have session-based or cookie-based authentication. Now in this whole illustration, this part here represents the client browser. And here we have the server side consisting of the Web API or the MVC application along with the database. And in between, you could see the request and response in between these two parties. So first of all, here we have the post request trying to log in into the web application here. And inside the server, the given credentials are verified. And if there is a user with given credentials, a new session record will be saved into the database, proving that this particular user is successfully authenticated into the system. As a response to this request, the session ID which we have saved into the DB will be returned. And then inside the browser or client side, the received session ID will be saved to the browser cookie. Inside your browser, if you open the developer tools, you could see application. Inside that, you could see the cookies related to each website. So for this application, these much cookies are saved. Similarly, the session ID will be saved to the browser cookie. And from there onwards, in order to access any protected resource from the web application, we have to pass the session ID as the cookie inside the request. And then inside the server side, before the request reaching its destination, the in-between authentication middleware will verify whether this session ID is present among active sessions. So while considering active sessions, the expired sessions will be ignored. And if this verification is successful, the request will reach up to its destination and then the proper response will be sent back to the client side. So that's how session-based or cookie-based authentication works. Now when it comes to token-based authentication, it is stateless, meaning that there is no involvement of database like we've seen in cookie-based authentication. There is no record saved in database proving that a particular user is successfully authenticated to the system. Now JSON Web Token authentication or JWT authentication comes under token-based authentication. So here it goes. First of all, the user makes a post request trying to log in into the web application. And then of course inside the server side, the given credentials must be verified with already stored users inside the solution. And if this verification is successful, then a token will be generated. In case of JWT authentication, the token is called as JSON Web Token, in short JWT. The same token will be returned as a response to the request, and then inside the client side or browser, the JWT will be saved somewhere persistently. That would be outside the browser cookie. Most often that would be the local storage inside the browser. You could see that inside this developer tools itself, local storage and all the local storage key value pairs for this website could be seen here. So a key value pair like this will be used for saving the received token as part of a successful authentication here. And from there onwards, in order to access any protected resource from the server side, we have to pass the JWT inside the authorization header of the request, in which along with passing the JWT, we have to pass the prefix bearer. Don't worry about this, we'll be showing you how to send this JWT inside the request authorization header. This part of validating token signature is really important because inside this token-based authentication, there is no involvement of database to check whether this user has already authenticated to the system or not. We could discuss that in a bit. So if the token signature is validated successfully, then the request will get the access to the protected resource, and then the respective response will be sent back to the client side or browser. So that's how cookie-based authentication and token-based authentication differs. Inside the cookie-based authentication, a record is saved to the database proving that this particular user is successfully authenticated to the system. When it comes to token-based authentication, there is no involvement of database for storing the record proving that a particular user is successfully authenticated to the system. So that's one of the important difference between these two types of authentication. Along with them, you could see the difference in how the session or token is saved inside the browser, and from there on how it is passed to the server for accessing protected resource. Now let's dive deep into JWT authentication and let's see how it is able to do everything without saving any state of the authenticated user in a database. For that, here we have the official documentation of JSON Web Tokens. So first of all, we'll discuss how the JSON Web Token is generated, and then we can discuss how it is getting validated in the subsequent request. So basically, JSON Web Token has three parts: header, payload, and signature. And each of these are separated with a dot or period symbol in between them. So typically, the header part consists of two properties or two informations. First of all, we have sign-in algorithm and then the type of the token. Since we are dealing with JSON Web Token, we will set it as JWT. And with this property ALG, which stands for algorithm, into that we have to pass the algorithm that we use for encrypting this signature here. I will explain that in a bit. So most often these two algorithms are used, SHA-256 or RSA algorithm. In a bit we'll be explaining how this algorithm plays a role in generating the JSON Web Token. So the first part of the token will be base 64 URL encoded version of this JSON object here. The intention or meaning of the URL encoding will be discussed later. And then comes the payload. So basically, payload consists of claims. Claims are statements about the entity that would be the authenticated user, and then some additional data about the token that we are generating. For example, inside this payload, you could see that the admin property is set as true, meaning that this logged user is an admin, and then here we have the corresponding user ID from the database, and here we have the full name of the logged in user. Along with these user related claims, you could see claims like this IAT. Those are the statements or additional information about the token that we are generating. You could see such predefined claims inside this documentation here. If you want to know what this means, we can search for IAT. See, it represents the time of issuing the token. So such informations or statements will be there inside the payload. Now before adding the payload into this JSON Web Token, the same will be converted into base 64 URL encoded version. In between both of these header and payload, there will be a period separating them. And finally, here we have the important part of this JSON Web Token, signature. Inside this signature, we are not hiding any extra information than what we have inside this header or payload. So this signature is generated using the algorithm that we have passed inside the header here. See, the same algorithm is used here for generating this signature SHA-256. So this encryption algorithm will take this part here from the beginning of the token up to this second dot here will be taken as the input for the encryption, and then the same will be encrypted with a secret key that we have passed to it. Now, as you know, the JSON Web Token is generated as a result of successful authentication of a user. So this secret key must be private and should not be exposed to anyone outside the server. As long as the secret key is not available, no outsider can modify or break into this generated JSON Web Token. More about that could be discussed once we generate the JSON Web Token. So back to the project. At present, we only added the services for authentication here, and the corresponding middleware is added here with the app object. So before generating the JSON Web Token, we have to configure the authentication with the authentication standard we are using. So that would be JSON Web Token. For that, we have to install the NuGet package to work with JSON Web Token. So right click on packages, then manage NuGet packages. Inside this browse tab, search for this NuGet package, which I have given in the video description. You can copy paste from the Authentication JWT bearer. Let's install the package. So the installation is successful. Now back to the Program.cs file. Now to this add authentication method, we'll be passing a lambda expression like this. Now inside this lambda expression, we are going to pass authentication options. So these are the available authentication options that we can pass to the lambda expression. So here we go, x dot default authentication scheme, and then we have default challenge scheme, and then we have the default scheme itself. All of these three schemes will be assigned with JWT. So here we go, JWT bearer defaults dot authentication scheme. Now it's necessary to know what is a scheme. It's a combination of authentication handlers and their configuration. So you could think of these authentication handlers as methods defining how to handle a requirement in the process of authentication, and along with its configuration options together is called as schemes. So back to the authentication options here. Along with the schemes that we are passing here, you could see other schemes inside this table that the ASP.NET Core identity is asking for. So this default authenticate scheme expects a scheme containing the basic core handlers related to the authentication process. And then this default challenge scheme expects a scheme containing handlers defining how to handle an unauthenticated request. And apart from these two schemes, authenticate scheme and challenge scheme, you could see other schemes inside these authenticate options. So for such schemes, we have not specifically set the scheme. So by setting this default scheme, all of such other schemes will be assigned with the scheme that we are passing here. So all of these schemes and rest of them is assigned with the JWT authentication scheme. So everything will be handled by JWT authentication scheme itself. In certain applications, there could be multiple authentication standards used. In those situations, these schemes could have different values or different schemes assigned to them. Now, we need to register the JWT scheme with necessary configurations. For that, we have to invoke this method, add JWT bearer method. Now, inside this method, we have to configure or tune the JWT authentication as per our requirements. For that, here we have the second lambda expression. First of all, we will say whether we want to save the token or not. Since we are going for JSON Web Token authentication, we will set it as false. Now we are going to specify how we want to validate the token for subsequent requests after a successful authentication. As I said already, how it works will be discussed once we generate the JSON Web Token. For now, let's configure how we want to validate the token. For that, we can assign this property token validation parameters. Now, in order to validate the token signature, we have to set this property as true. And to do the same, we need the secret key of the encryption. This secret key, we need this for validating the JSON Web Token. So here we go, issuer sign-in key is equal to this option only accept an instance of this class symmetric security key. Inside that we want to pass the encoded version of the security key. Now we'll save the security key inside this AppSettings.json file. So here we go, app settings. Inside that we'll have this secret key JWT secret. Now this secret key must be having at least 32 characters. For this demo project, we have set the requirement of the secret key itself as the secret for the JWT authentication. So make sure to provide the secret key having 32 characters. Now let's pass the value of this key to this method getBytes. So here we go, builder.configuration. Now let's provide the path of the key. So inside app settings, we have JWT secret. Now you could see a green squiggly line here saying there is a possibility of null inside this key. We already provided a value for this key. So at the end of passing this key, you can add this exclamation mark like this. So in this way, we can turn off the possible null error warnings when you can always ensure a value in the context. So first of all, we have reset this Boolean property saying that we don't want to save the JSON Web Token after its creation. And with this property, we have specified how we want to validate the JSON Web Token in the subsequent request after a successful authentication. We want to validate the signature of the token, and here we have provided the necessary key or secret key for the validation purpose. We will be discussing how the signature is getting validated once we generate the token. Now it's time to create a Web API method for login or sign-in operation. So we'll be making a post Web API method with this URL. Inside the body of the request, we'll be passing the email address and the password of the user. And inside the Web API method that we are about to create, we will check whether there is a user with the given credentials inside the DB with the help of ASP.NET Core Identity User Manager. And if it is successful, we'll create the JSON Web Token. And finally, from the Web API, we'll be returning the JSON Web Token to the client side. So at present, inside this Program.cs file, here we have the Web API method that we have created for user registration. So let me copy this and let's forward this Web API method. And just beneath that, we can add this Web API method with this URL sign in API/sign in. And here we have the Lambda expression to handle the request. Now let me copy paste the parameter from this user registration Web API method. We need the user manager. In order to receive these two credentials, email address and password, we are going to create a model class like we have done for user registration. For that, let me copy paste this. This is login model. Inside that, we only need email and password. At present, this Program.cs file is messy. We will be organizing everything into respective files and folders towards the end of this video. Now, instead of user registration model, we have login model. And let's rename this parameter also. Now, with the help of this user manager, we have to find if there is a user with the given credentials or not. So here we go. User is equal to user manager dot find by email async method can be called. Into that, we can pass the email from the model that we have here. Now, since we have an async method here, we can prefix the method with the avoid keyword, and that requires an async method just before this lambda expression here. Now we have only checked if there is a user with the given email address or not, because we can't check for the received password inside the DB. During the user registration itself, the password is hashed. So for that, we'll be using a separate method. So here we have the if clause. First of all, we'll ensure there is a user with the given email address. And here we'll do the password comparison. For that, we can invoke this method check password async. As a first argument, we have to pass this user object itself, and then we have to pass the password that we have received through the request body. Now this method will check whether the given password is the correct password for the user. Now, if it is successful, we'll handle the request inside this if clause here. Else, we'll return a bad response. So here we go, return results dot bad request. Inside that, we can pass this object. Message is equal to username or password is incorrect. Now, inside this if clause, let's go ahead with generating the JSON web token. For that, first of all, I will save the encoded version of the secret key that we have here into a variable. So here we go, sign in key. Now actually we are already done that inside this JWT configuration options here. So let me copy this and pasting the same here. Now we want to describe the token that we are about to create. So that would be deciding what are the claims or informations that we want to add into the payload. Once the header and the payload is available, the signature could be generated or encrypted with the algorithm that we have specified here using the key that we have saved inside the AppSettings.json file. So all we have to do is just describe what are the informations or claims that we want to pass into the payload of the token. So here we go, token descriptor. Into it, we'll be assigning an instance of this security token descriptor. Now through this property subject, we can pass the custom claims like user ID, role of the user, etc. and etc. So into this property, we'll be assigning an object of this class claims identity. And the constructor of the class expect an array of claims. For now, we only have a single claim. Inside that, we'll be providing the user ID. So here we go, new claim. The name of the claim will be user ID. Now the user object corresponding to the credentials that we have here will be the inside this user object here. From that, we can access the user ID. And let's convert it into string format. So at present, we only have this custom claim. As per the future requirements, we can add necessary claims into this token generation process. Then after the custom claims, we can set the expiry for the token. Instead of add days, let's invoke add minutes method. So the newly generated token will expire after 10 minutes. And finally, with this property sign-in credentials, we have to pass the sign-in key that we have saved inside this JSON file, along with the algorithm that we want to use for the encryption of the signal part. So here we go, new sign-in credentials. As a first parameter, we have to pass the sign-in key here. Then as a second argument, we can pass the algorithm, security algorithm. This particular algorithm could be passed, SHA-256 signature. So here we have passed whatever we needed for the payload, and here we have passed the sign-in key along with the algorithm that we want to use for the encryption of the signature. Finally, in order to create the token, first of all, we want to create an instance of token handler. For that, we can create an instance of this JWT security token handler. Now let's create the token, security token. From this token handler, we can invoke this method create token. Into that, we only want to pass the token descriptor that we have created here. Now finally, in order to convert this token into a serialized format, we'll create a variable token. So this is the actual token that we want to pass as a response to the post request. All we have to do is from the token handler, we can invoke this method write token. Inside that, we can pass the security token here. Now all we have to do is just return the response within this OK method. We have to return it within an object token. Now let's build the project. Now back to the Swagger UI. So here we have the post request that we have just created, API/sign-in. Now click on try it out. Now let's pass the user credentials of the user that we have created in previous video. So email is equal to email@gmail.com. And then we have password. The correct password was string, then a pound symbol or hash symbol. Now in order to test the working of this web API method, let's try with wrong credentials. So I will set the password as string. Click on execute. So here we have the bad request with the message username or password is incorrect. So that is from this else block here. Now before passing the actual password, let me increase the expiry time using the method addDays, so that we can avoid the situation where the generated token will get expired before explaining the related topics. So let me build this project again. So that will reload this API Explorer here. Let's try to make the same request, but this time we are providing the correct credentials, email, then password. Click on execute. Boom. See, here we have the JSON web token. Now let me copy paste the same into a notepad for closer inspection. So first of all, we have the header, then payload, then finally signature. All of them are separated with a dot in between them. So here we have successfully implemented the Web API method for login or sign-in operation. First of all, we have checked whether we have a user inside the stored list of users with the given credentials here. And if there is such a user, the Web API will create the JSON web token and it will be returned as a response back to the caller. So inside the previous illustration about token-based authentication, we have completed this part here. Now when we make this post request from the Angular app, the received token will be saved somewhere persistently outside the cookie. Most often, browser local storage is used. We'll do that in a bit because we need to pass the same for accessing any protected resource from there onwards. And once such request asking for protected resource reach in the Web API, the passed JSON web token will be validated inside the server side. Now let's see how the token or token signature is getting validated inside the server side. For that, I will make use of this debugger inside this official documentation. Now let's switch into the dark mode. So this is how it works. If we provide the received token here, the containing header and payload will be decoded here. And with this last portion, we can verify the signature. So let me copy this and pasting the same here. Let's remove the new lines that we have added. Now you could see the decoded header and payload of this token here. Here we have the algorithm that we have used, SHA-256, and here is the type of the token, which is JWT. Inside the payload, you could see the ID, user ID that we have passed inside the Web API method. You could verify that from this user's table here. See, the same ID is the pass into the payload. Then we have the expiry time as per the configuration we have given during the token generation process. Now, other than those two, we have IAT, which stands for issued at time. NBF stands for not valid before, which exactly have the same data that we have inside the IAT, meaning that this token is not valid before the issued time here. Okay. Now you should be careful while describing the token like we have done here. Whatever we pass inside the claims or payload can easily be decoded because the URL encoded format of the payload is directly added to the token. Now the process URL encoding is the process in which the characters that we have is converted into a format that can be transmitted over the internet. To be specific, the converted output from the process should be safe to pass within the query strings of the URL. So that involves replacing special characters in the data with respective encoded versions. So make sure to avoid passing crucial data through the payload. It could be easily decoded by pasting the JSON web token inside this part. Can also be decoded easily with the respective decoding methods. For example, in case of JavaScript, if you pass this payload here into this method atob, we will get the decoded version. Let me try that here. atob, inside that, let's pass the string. So here we have the encoded version of the payload. Now let's execute the method. You see here we have the string version of the payload that we have passed inside this JSON web token. You could see the same here also. So that's how easy it is to decode the URL encoded version of the payload or header. Now the actual protection is there inside this third part here, signature. Now like we have discussed previously, this signature is formed by encrypting this part here from the starting of the token up to this second dot here. And for the encryption process, we have passed a secret key. Now, during the process of validating the token signature, the signature part will be recreated by encrypting this part with the signature that we have saved inside this server side here. Now let me illustrate the same with this debugger's third part here, verify signature. Inside this part, this much portion will be taken as the input for the encryption using this algorithm SHA-256 using the secret key that we provide here. So whatever secret key you provide here, this much portion will be encrypted with the key that we have provided here. And the result will be updated in the signature part of the token. And here you could see the feedback saying signature verified. So meaning that this signature is the exact encryption of this part with the given secret key here. That's exactly how we create the signature. Now whenever we change any of these values inside this header or payload, you will get this feedback invalid signature. Meaning that encrypting this much part with this given secret key does not match this signature here. So that's how the debugger validation feedback works. Let me undo the change that I have done. Now let's go ahead with the actual procedures involving invalidating a token signature. Inside this notepad, we have the original JSON web token. So during the verification of the signature inside the web API, this much part will be encrypted with the key that we have saved inside this app settings here. And then the resulting signature will be matched with the received signature. Let's see them in action inside this debugger. For that, first of all, I will clear this signature. Now let's copy paste the secret key inside this debugger here. Now this signature will be matched with the received signature. See, both of them match each other. And thereby the verification of the token signature is successful. The user will get access to the protected resource. And if needed, they can make use of the information that is received through the token payload. Now let's see how much safe is a JSON web token. Suppose a hacker got this token from someone successfully authenticated to the system. They can easily decode the payload, and if they want to change any of the information like user ID, role or whatever it may be, they can do it without a problem inside the payload. But during the token verification process, it will be caught because inside this signature, the original payload is encrypted. So anyone outside the server can't do anything without the secret key that we have saved inside the web API. So this token is protected by itself because there is a signature of the actual data passed through the token. So hope you understood how the token signature is getting verified while accessing a protected resource. Now this will be done in action while doing the authorization. We'll discuss that in the next video. Now back to VS Code and let's make a post request to this Web API method sign in from this Angular app login form submit event. So here we have the login form submit event. We'll make the post request if the form as a whole is valid. So here we have the if clause. Inside that we want to check whether the form as a whole is valid or not. Now to make the post request, back to the auth service clause. Here we already have a method create user for making the post request for the user registration. Now let me copy paste that for making the post request to the sign in Web API method. So here is the function sign in, and here we have the parameter to receive the form data, and this will make a post request to this given URL here /sign-in. Along with that we'll pass the form data having the email and password. And the return observable from this post method, we have returned that from this function sign in. Now back to the login form component. First of all, we have to inject the service clause here. Private service, which is of the type auth service. Now back to the function on submit. Let's invoke the method sign in, service.signin. Into that we want to pass the form data. Now we can make the subscription to the return observable like this. With this next property, we can pass the success callback having a single parameter response which is of the type any. And with this error property, we can pass the error callback. If there is a user with given email and password, the authentication will be successful. So we can handle that inside the success callback here. So inside the return object, there will be a property called token, which we have already seen while making the post request inside the Swagger UI. So the return JSON web token will be there inside this property. Now we have to save this into the local storage. For that, we can make use of the set item method from the local storage. As a first parameter, we have to pass a name for the key that will be token. And then second parameter will be the value that we want to save into the token. So let's pass this token here. Now after the successful login operation, we want to redirect the user to the dashboard, which we have already created here, dashboard component. So first of all, let's add a corresponding route inside this app.routes. For now, I will do this path is equal to dashboard, and we want to render this component dashboard. So this component, dashboard component, will be replaced inside the router outlet inside this default app component here. Okay, so back to the login component. In order to redirect from this component, first of all, we have to inject router into this component constructor. So let's add the corresponding constructor parameter router. Now inside the method, we could do this router.navigate by URL method can be called. Into that, we just need to pass the path that we have given for the component dashboard. So this is how we handle a successful login operation. Now suppose there is no user with the given credentials, then from the Web API we are returning a bad request. So the corresponding response status code will be 400. So with that, we can catch the error or response inside this error callback here. If the error status code is equal to 400, we want to show a toaster notification. So first of all, inside the component constructor, let's inject the toaster service, private toaster, which is of the type toaster service. Now we could do this toaster.error method can be called. As a message, we can pass this incorrect email or password. And here we have the title, login failed. Now if there is any other error, we can handle that inside this else block. We will just print the error object like this. Let's save this. Back to the app. Let's open the developer console. First of all, let's start with incorrect user credentials. Submit the form. See, here we have the toaster message, incorrect email or password. Now let's try with the proper user credentials. email@gmail.com, and here is the password. Submit the form. Boom. See, here we are redirected to the dashboard. If you check the local storage, you should see the respective JWT token that we have just created as part of this successful authentication. See, inside this local storage, here we have the JSON web token that we have just saved as part of the recent login operation that we have made. Inside this dashboard, we have to deal with the logout operation. We'll do that in a bit. Before that, let's implement the Angular fade-in animation inside this navigations, sign in and sign up. So basically, the animation is going to be applied into the content that we are going to render inside this wrapper div here. At present, we have sign in and sign up form. In future, we may also want to implement the provision for forgot password. To do that, we'll be adding one more child component to this parent component user. So we'll be showing the same inside this same wrapper div here. So the animation will be applied to this parent component to this div here. So whenever there is a change of component rendered in place of this router outlet, there will be a fade-in effect. If you want to know more about Angular animations, you can go to this official documentation here. So as you know, we are going to apply the animation inside the parent component user. So first of all, open the corresponding TypeScript file. First of all, inside this app.config.ts file, we have to provide the necessary dependency injection related to the animation, which we have already done as part of the toaster service. So don't forget to invoke this method inside this app.config file. Now back to the user component. First of all, inside the component decorator, with this animations property, we have to define the requirements of the animation. For that, we can pass this array. To define the animation, first of all, let's import the necessary functions from Angular animations. So these are the functions: trigger, style, animate, transition, and query. From the name of this function, you could tell what's their purpose. So with this function trigger, we'll define the animation. As a first parameter, we have to pass the name of the animation, that will be router fade in. Now with this second argument, we can define the animation that we want to do. So here we have the animation transition, and that will be happened when this condition is met. It's like a wildcard expression. The exact meaning will be discussed later. Now whichever transition we want to do when this condition is met, we can pass that as a second argument inside this array. So here we have invoked this method query. Inside that we have an expression. You could think of it as a selector. So with this selector, call and enter, we are going to apply the animation on the element that is being added to the router element here. So that will be the new component replacing the previous component. So the new component will get the fade in effect. Now with the second argument array, we can pass the animations. First of all, we have set the opacity to 0. So initially, the component that is being rendered, its opacity will be set to 0. And then within 1 second, it will be gradually within 1 second, the opacity will be incremented to 1. Now as a third argument to this query function, we'll pass this object having this optional set as true, meaning that we don't want an error when there is no component with this given selector. So this is how we define an animation. If you want to know more about any of these animations functions, you can go to the official documentation and search for the function like transition and look for the reference article transition. You could do the same for rest of the functions also. Now with this animation defined here, let me copy the name of the animation. Back to the component HTML, this is what I'm gonna do. I will pass the animation with a prefix @simple like this. Into that, we want to pass an argument. So that will be the value returned from this function getRouteURL. I will tell you how this works. First of all, let's define this function. So back to the component TypeScript file, and here is the method getRouteURL. Now this function should return the current URL of the app. To retrieve that, first of all, we have to inject the children outlet context. So here we go, private context of the type children outlet context. If you want to know more about this class, you can go to the official documentation and let's search for the same. See, it stores the contextual information about the children, meaning that whatever the route URL for these children can be received with this class object children outlet context. So here we go. From the context, we can invoke this method get context. Into that we'll pass primary. So that is referring to the direct children. From that, we want to retrieve the route and let's return the URL. So this function will return the URL of this router outlet context, and we have assigned that to the animation that we have defined. So that will be considered for the condition that we have defined here, this one. So whenever there is a change of URL inside the router outlet, this animation will be executed. So hope you understood how the animation works. Let me save this back to the app. At present, we have not given a proper URL. So let me set the default URL as the login component. So here we go, path is equal to empty. Then we want to redirect to /signin. Make sure to set this property path match as full. Sorry, here we have a typo, sign in. Save this back to the app. See, during the back and forth navigation, we have the fade in effect. Now let's go ahead with implementing the logout operation. For that, first of all, inside the dashboard component, let's add a button for logout. So here is the component HTML. Instead of this default paragraph, we have a button having these bootstrap clauses btn, then btn dark. Inside that, we will show this logout. And let's fire up a click event. We'll handle the click event inside this function on logout. Now let's define this function inside the TypeScript component. When the user is successfully authenticated to the system, we only save the token into the local storage, as you can see here. So during the logout operation, we will do the reverse. Let's copy this statement back to the component dashboard. Let me paste that here. In order to remove the token with this key token, we just need to invoke this method remove item. That's it. Now after that, we want to redirect the user back to the login form. For that, first of all, we have to inject the Angular router. So here we go, private router of the type router from Angular router. With that, we can invoke this method navigate by URL. Into that, we can pass this path /sign in. Let me save this back to the app. Here we are inside the dashboard already, and you could see the logout button here. Now before trying it out, let me open the local storage. So application, and here we have the local storage. Within the key we have the JSON web token. Now click on this logout. See, here we are redirected back to the login form. At the same time, the token is deleted from the local storage. Now as part of authentication, we have to set up protected routes inside this Angular app. For example, the user must be prevented from directly accessing the dashboard through typing the URL like this. We'll do that in the next video as part of authorization. Along with that, we'll be adding a neat layout for the dashboard component here. Now finally, back to ASP.NET Core Web API, and let's organize whatever we have inside the Program.cs file into respective files and folders. So that's what we are going to do in rest of this video. So here is the initial Program.cs file, and here is the final output. Before getting into that, we should be familiar with the C# extension methods. Keep in mind that it's not static methods, the feature is called extension methods. Now consider this part as our Web API project. Into that, we have added a necessary framework called ABC. Now suppose inside that we have an interface or class called original. The implementation of this type original is already done within the framework with its own methods and properties. Now using the C# feature extension method, we are going to extend this type original by adding our own methods from this Web API project here. Say we have an object org1 which is of the type original, that is from this framework here ABC. Now using the C# extension methods, we have added these two methods into the type original. Now let's see how it is done. So first of all, we have a static class. Inside that we have two extension methods for this type original. All we have to do is the method must be static and the first parameter to the method should be of the type original. And make sure that the parameter is prefixed with this keyword this. Then such a method will act as a method defined inside the type original. And that's how we are able to invoke these two methods from the same type. Even though both of these methods are not there inside the original implementation inside the framework here, we could add methods like this from our Web API project like this. Finally, there is a warning. Make sure that there is no such method already present inside this original implementation here. We can't override an existing method with this feature extension methods. Now we are going to make use of this feature for organizing the Program.cs file. Now first of all, inside this Program.cs file, let's add extension method to the type of this services collection. You could see that it is having the type of this interface iService collection. So to be specific, we are going to add an extension method to this interface iService collection. For that, first of all, I'm going to add a new folder called extensions. Now inside the new folder extensions, we are going to add a C# class file corresponding to this outer static class here. So here we go. Inside the new class we are about to create, we'll be adding extension method related to ASP.NET Core identity. So I will name this class as identity extensions. Now, some of you might have noticed it. The outer static class name is nowhere mentioned while invoking these containing extra methods. See? And for the same reason, we should be providing some meaningful name for the outer class. Like we have given here. Inside this class, we'll be only having extension method related to ASP.NET Core identity, and thereby you could easily navigate the extension method inside the project. So first of all, we have to make the class as static class identity extensions. Now I'm going to add an extension method for what we have done here, in which we have added services for identity handlers and corresponding entity framework stores. So here is the new extension method, public static void. I will name the method as add identity handlers and stores. Now we have already made this method as static like we have seen here. Now we also need a parameter of the type iServiceCollection, which is the type of this services here, iServiceCollection. So here we go, iServiceCollection. Now we'll name this parameter as services. As a prefix, we have to use this keyword this. So here we go. Now this method add identity handlers and stores became an extension method of this type iServiceCollection. So you can invoke this method from this type iServiceCollection from this program.cs file like this. Builder.services.add identity handlers and stores. So this is the method that we have just added, the extension method. Now let me cut this and pasting the same inside this new extension method. The iServiceCollection is already here as a parameter, so we can invoke these methods from these services here. So here we go, services.add API endpoints and then add entity framework stores. So this is how we are going to add extension method throughout this program.cs file. Now, the proper naming of extension methods like we have done here will help you to remove comments like this. Now, here we have configured the properties of user, password and email address for user registration. So to do the same, I'm going to create another extension method. For that, I will just copy paste the signature of this method. I will name this method as configure identity options. Let's move this statement into the new method. We can invoke this method from this services parameter itself. So here we go. Sorry, here we need an extra curly bracket. That's it. Now we can invoke this new extension method from this program.cs file. Builder.services configure identity options. So hope you are realizing that how C# extension method is helpful to organize codes like this. Now we could make this even more better. Instead of returning void from this extension method, we can return this interface type iServiceCollection. So at the end of invoking these methods, we have to return these services like this. Return services. Let's do the same for the second extension method also. We have set the return type as iServiceCollection, and after invoking these methods, we have returned the services here. Now by doing this, instead of invoking these two methods separately from the services, we can change the invocations like this. This method is already returning an iServiceCollection. From that, we can invoke this second extension method. So all we have to do is just change the invocations, method invocations like this. Okay. Now let's define an extension method for injecting the DB context here. It's not related to identity, so I'm going to create a new C# class file, entity framework or extensions. Let's make this class as static. Now here we have the extension method public static Now instead of defining from start, let me copy this signature from here. I will name this method as inject db context. Now let's move this statement for the db injection into the new extension method here. We can invoke this method add db context from the service parameter. Let's add the required using statements. Now to this method use SQL Server, we have to pass the db connection string that we have saved inside this JSON file here. For that, we have to pass this configuration from the Program.cs file. So first of all, let me add a parameter of the type iConfiguration. Let it be config, and we can invoke this method getConnectionString from this config object. At the end of this method, we have to return the services. So here we go, return services. Now let's invoke this method inject db context from this Program.cs file. That we can do through chain invocations like this. Into this method, we have to pass the builder.configuration object. Now, instead of naming this method as inject db context, we could have named it like add db context. But such a method is already present inside the type iService collection. That's what we are invoking here. So that's the reason why we have named it like inject db context rather than add db context. As I already told you, we can't override an existing method with an extension method like this. Now, in previous video, we have added authentication services from ASP.NET Core with this method invocation. Inside that, we have given necessary configuration for JSON Web Token authentication. For that, I'm going to create a new extension method inside this identity extensions. First of all, I will copy paste this last extension method. And let's clear everything inside that. I will name this method as add identity auth. Often I use this abbreviation auth to mention operations combining both authentication and authorization. At present, we have only added the authentication services. In next video in this series, we'll be adding authorization also. So that also will be done inside this method add identity auth. So let me cut this and paste the same here. Let's invoke the method from services parameter. Now here also we need the configuration object. So we have to add the second parameter like we have done here. Let me copy this and pasting the same here. Now let's replace this builder.configuration with config. Now back to the program.cs file. Let's invoke the new extension method add identity auth. As an argument, we have to pass the builder.configuration object. Now if possible, change the order of invoking this method for better grouping. Everything related to identity will be called in sequential order. So first of all, I will invoke this inject db context. Then we have add identity handlers, then configuring the identity options, and then we have added the services for authentication and authorization. As you can see, the program.cs file is already getting cleaned. Now, as the next step, we want to add extension method to the type of this app object. Before doing that, I want to add one more extension method for statements related to Swagger UI. For that, I'm going to create a new C# class file, Swagger extensions. So here we have the static class. Now let me copy paste an already existing extension method. I will name this method as add Swagger Explorer. Let's clear everything inside the method and let's cut and paste what we have here. Let's invoke this method from this services parameter. Now let's invoke this method inside the program.cs file. Add Swagger Explorer. For now, I would like to keep this add controllers method as it is. Now we need to add few more extension methods to the type of this app object. First of all, here we have the if clause to configure the Swagger API Explorer. For that, I'm going to add a new extension method to the Swagger extensions here. Let me duplicate this last extension method. Previously, we have been adding extension method to the type of this iService collection. But in case of this app object, we have to add extension method to the type of this class Web Application. So we have to change this parameter accordingly. Instead of this interface, we want to extend this class Web Application. I will name this parameter as app. We want to return the same type from this method. So let's change the return type to Web Application. Now let's rename this method as configure Swagger Explorer. Let's empty the method. And finally, from this method, we'll be returning this app object. Now let's move this if clause into the new method here. Now we can invoke the method app.configure Swagger Explorer. Now inside this region, we have configured the course middleware for the Angular app. So let's create an extension method for the same. For that, into this extensions folder, let me add a C# class file app config extensions. So here we have the static class. Let me copy paste the last extension method that we have created here. I will name the method as config course. Let's clear the method. Now let's move this use course method invocation into this new extension method here. Now we don't need this region anymore. Now we can directly invoke the method here config course. Now you know what, for configuring the course, we may need data from this AppSettings.json file. So in those situations, we have to pass the configuration object like we have done here. So let me copy paste the same here. Now we have to add the necessary parameter inside this extension method. iConfiguration as config. Okay. Now let's add our final extension method for adding these authentication and authorization middleware that we can do inside this identity extension clause. For that, first of all, let me copy paste this extension method into the class here. I will name the method as add identity auth middlewares. Let's clear everything inside the method and let's move these two method invocations into it. Let's cut this and paste the same here. Now let's invoke this new method like this. Actually, we could change this method invocation to the invocations here. So I will do this. So far, with the help of C# extension method, we have organized every method invocations related to adding services and configuring services like this. Now, rest of the portions inside this Program.cs file deals with Web API methods. First of all, you could see this method invoked here, map controllers. It will configure or add routes from traditional controls like this weather forecast control. This is the default control that's already been there inside the new project template. So the routes from conventional Web API methods like this will be added with this method invocation here, map controllers. But so far inside this project, we have used minimal Web API methods. And that's how we are able to define the methods inside this Program.cs file itself. But doing all of them here kind of mess up the whole purpose of Program.cs file. Now let's organize these Web API methods properly. Now before this user registration and login Web API methods, you could see this method invoked here, map identity API. We have invoked this method for adding routes from identity framework into this project. And rest of these Web API methods are custom Web API methods that we have added throughout this series. Now let's look how to organize these Web API methods or the Web API methods that we are about to add going forward in this series. We are going to use the same concept that we have used so far, that is C# extension methods. Let me walk you through it. Inside this controllers folder, I'm going to add a C# file. I will name it as identity user endpoints, like we have done for these extension classes here. We are going to make this class as static. Now, inside this class, we'll be adding Web API methods related to the entity identity user. For that, first of all, let me copy paste an extension method that we have already created here. So far, we have been adding extension method to the class Web Application or the interface iService collection. But in order to work with minimal Web API methods, we have to extend this interface endpoint router builder. I will keep the parameter name as it is, app, and I will set the same type as the return type of this method. Now let's rename this method as map identity user endpoints. Let's clear everything inside the method. So as I said already, inside this class, we'll be adding Web API methods related to the entity identity user. So both of these Web API methods will be added into this class here. So from this Program.cs file, we can invoke this method map identity user endpoints. Now you might be asking this. Here we have added this extension method to the type of this interface endpoint route builder. But here in this Program.cs file, we have invoked the method from the type of this app, which I present inside this Program.cs file, which is having the type of this class Web Application. How it is possible? It is possible because this interface here is a derived type of the class Web Application. See, this interface is derived from this class Web Application. So the parent type can invoke the children methods. That's what exactly happened inside this Program.cs file. We have already done the same while defining these two Web API methods here. This method map post is actually a method of this interface endpoint route builder. And here we have invoked it from the parent type app, which is having the type Web Application. See? So let me move these two Web API methods into the new method here. Along with these Web API methods, we also need these two classes. So let me cut this and pasting the same outside this class here. Now let's add the required using statements. Now here you could see an unresolved error due to this builder object. It was readily available inside this Program.cs file, but inside this endpoint class it's not available. We'll fix that in a bit. Now we can organize these Web API methods even more better. For that, outside this extension method, I'm gonna create a private method like this, private. This class is already static, so the containing method should also be static. And here we have the method create user. Now we are going to move this lambda expression into the new method that we have created here. For that, first of all, I will cut everything inside this lambda expression and pasting the same here. And let's cut these parameters here. Now from this method, we are returning an HTTP response. So we have to provide the corresponding return type for this method. That will be task of the type iResult. Now all we have to do is just replace this method in place of this lambda expression here. Now since the method contains asynchronous operations, we have to prefix the method with this async keyword here. Now let's do the same for the second Web API method for the sign-in operation. Let me copy this method signature from here. I will name this method as sign-in. Now we have to replace the method parameters with what we have inside this lambda expression. Now let's move everything what we have inside this lambda expression. Now instead of this lambda expression, we can pass this method sign-in. That's it. So with this method invocation inside this program.cs file, map identity user endpoints, we have mapped every web point related to the entity identity user. At present, it contains the Web API methods for user registration and sign-in operation. Now, in order to avoid repeating this part of the URL in all of the Web API methods, I will invoke this method map group before registering the Web API endpoints like this. So all of the containing Web API methods will get this prefix in the URL. So we no longer need to repeat this part of the URL /API. So this is how we are going to deal with Web API methods. Now of course inside your project you will be dealing with different entities. Suppose you are creating this Web API for an e-commerce website. In those situations, you will be dealing with orders. So, to define Web API methods related to the order, you will be creating a separate class like we have created here. For example, let me add the class file order endpoints. You will change this class into a static. Inside that, you can define an extension method like we have done here. That will be map order endpoints. So all of the Web API methods related to the order can be added to the extension method like we have done here. At the end, in order to add such Web API methods into the project, we can invoke the extension method map order endpoints here. So that's how to deal with Web API methods. Now finally, we have to resolve this error related to accessing configuration data from the builder object. This builder object is not available inside this class here, identity user endpoints. But we could pass the builder object from this program.cs file like we have passed the builder.configuration in rest of the extension methods here. But that's not a best practice when it comes to Web API methods, because we'll be passing first to the map method here. From there, we'll be passing the same to this method sign in. In order to avoid the inconvenience in passing the builder object, we can make use of dependency injection. Let me show you the proper way to do it. For that, first of all, I'm going to define a class representing the data inside this AppSettings.json file. Because inside these methods that we have created here, it is trying to access the configuration values. So first of all, I'm going to define a class inside this models folder, AppSettings. At present, with this class, I want to represent this key here, AppSettings. As you go further with the app development, you will be adding more key value pairs into this AppSettings. So all of those properties could be added to this class here. So at present, we only have this property JSON secret. So let me copy this and let's define a property with the same name, which is of the type string. So here we have created a property with the same name as that of this key here. Now back to program.cs file. Now like we have injected an instance of this DB context, I'm going to inject an instance of this class AppSettings with the corresponding value that we have inside this AppSettings.json. So here we go. From this services collection, we can invoke this method configure. Now here we have to provide the type of this class AppSettings. Now into this method, we have to pass this section here, AppSettings. So here we go, builder.configuration.get section method can be called. Inside that, we can pass this section, AppSettings. So with this statement here, an instance of this class AppSettings will be created, and the containing properties will be assigned with the value with the corresponding key value pairs from this section here. Now, any Web API method can access the properties inside this app settings if there is a corresponding parameter inside the Web API method. So for example, for this Web API method, sign in, we have to access this JWT secret. So we can do this to this method. We'll add this parameter iOptions of the type AppSettings class, and we'll name this parameter as AppSettings. Now, in order to read this key JWT from the JSON file section AppSettings, we could do this AppSettings. Inside that, we have this object value which is corresponding to the class here AppSettings. From that, we can access this property JWT secret. See, that's simple. Like this, you can access any property that is added to this class AppSettings. So that's how to do dependency injection for properties or values or informations inside this AppSettings.json file. Now finally, let me move this into a new extension method that we can do inside this class app_config extensions. For that, let me copy paste this extension method for the DB injection. I will name it as add app_config. Let's clear the method. Let's cut this and paste the same inside this new extension method. Instead of builder services, we can make use of the services parameter. We already have this object inside this parameter config. That's it. Now let me invoke this extension method just after the injection of the DB context. Here we have to pass the configuration object builder.configuration. That's it. So that's it, guys. In this Program.cs file, we have organized everything into respective folders and files with the help of C# extension method. So before going forward, let's verify the proper working of the Web API methods that we have done so far inside this project, that is user registration and user login. So let me run this project. First of all, let's create a new user. Let's make the request. So here we have successfully created the user. Now let's try to log in with the same credentials. For that, here we have the post request sign in. Try it out. Let's make the post request. Boom. So here we have the JSON web token as a result of successful authentication. So that's all for this video, guys. In the next video, we'll be discussing user authorization. You can clone or download this project from the GitHub repository link given below in video description. If you haven't subscribed to the channel yet, please consider doing it now. Please like and share this video with your friends and colleagues so that they can also benefit from this. Have a nice day. See you in the next video.